SQL query if you haven't done so already. Find the name of female movie stars and what are the title of movies from prior to 1939. Okay, so write those out and then we'll go over them together. This is a good starting point again. Select from where and then add whatever you know to each of those lines. Alright, and click when you're done. Okay, so when I want to start this, we're going to look at select from where. My first question is where from. So what table am I talking about? Talking about name of female stars. So I need to look at that movie star to find their name and their gender. So from movie star, what's the condition? The condition is that I want gender to be female. So now I can add the condition. What do I want to return? I want to return their name. Right? So start with from, then get to where, and then see what you want to return. What are the titles of movies prior to 1939? So I'm talking about year, so I need to look at movie. What do I need? So the table is movie. The condition is I want year to be smaller than 1939, so I can add that. What do I want to return? I want to return the title. Any questions? So if you run these, so this is going to return the name of female stars. You can also see the number of rows which is being returned. I have 137 female stars. Again, instead of name, I can do star. And that gives me more information about these people. What if I do gender? What am I going to get back? I'm going to get 137 female. Not the most exciting query, but this also shows you that you get duplicates. And if And also reassuring to not see any males here. So the where is working. Let's try this one as well. So where movie is smaller than that. This is their title. And if you look at star, then you can see all the values in the year column are all smaller than 1939. And I can also see that I have 26 movies which were made prior to 1939. Any questions? Okay, now if you want to find the person, name, and character of those who've been in a movie, that means we're talking about two tables at the same time now. We're talking about stars in, and we're also talking about whether to find the character that is being played. So how can we do joins? And where does join go if you want to do an SQL query? We know that the projection goes into the select part. We know that sigma, or the selection, goes into the where part. The join also goes into the where part. Okay, so we'll add that as conditions as well. So I can do select, we'll talk about what later. From, I can have multiple tables in the from part. I have stars in, and I also have movie stars. Note that I can use alias in order to avoid writing out the whole thing every time. So I'm using an alias S for star in, and M for movie star. So that means now I can say S.starId instead of writing out star in, stars in dot star ID. And I can say M.starId instead of saying movie star. If you have multiple tables in your from part of the query without any conditions on them, that's going to give you the cross product. If I say select star from stars in S and movie star M without any conditions, that's going to return the cross product of the two. If I add any limitations or anything to my where part, then it's going to restrict the tuples to the ones which actually make sense based on the where part. Alright, so this is quite close to the one that I just showed you, but write it out so you know how to write them out. Again, if you're lost, this is a good starting point. And click whenever you have an answer. And statistically, most people press A when they just want to press it. Okay, so let's first figure out what tables we need. We need name of people that have starred in a movie. So we need star in and we need movie star. So these are the two tables. I'm using alias S and M for them. What's the condition? Well, I want the star ID to be the same in both of them. So that star ID needs to be the same. What do I want to return? I want to return the name. Right? So here, you get back the name of stars that have played in a movie. This is returning 316 rows. If I check, I only have 275 actual stars. And out of that 275, it seems like 316 of them have played in a movie. Why is that happening? I have duplicates there. Right? And we get back to how you can get rid of those duplicates soon. But really, if I'm asking you to give me the name of stars that have played in a movie, I don't expect you to give me more stars than I actually have. Any questions?
Right, now let's do a clicker question.
This one's quite hard. Think about it on your own for a bit, and then I'll ask you to discuss it with your neighbors. Alright, let's finish the first round in 5, 4, 3, 2, 1. Right, discuss it with your neighbors.
Wait, but are you actually doing
There's a cross product. It's selecting from the cross product because if it is, that's when you have front, that is a cross product, but I'm not sure.
Okay, so one way to approach this, if you're a little confused, is to take each of these tuples and try to see how you can get that. right? So look at, for example, the first one and see what it is you need from R, from S, and from T in order to get such a tuple. And then move to the second value and see whether you can find out how many different combinations you can get for each.
Oh, it's just not what's returned.
Either two of them, one and more than one, or it's like R and 0,
Right, and 4 people got the right answer so far. But it could be you. You don't have to change your answer.
But yeah, it does. But it appears like one. It appears one on one.
You have almost tripled the number of right answers.
Wow, so close.
I thought it's an A or E. R is equal to F. You just can't see it. Because S is
Right, let's finish this off in 5, 4, 3, 2, 1. Maybe random this might help. Okay, so obviously E is not the right answer. Okay, so what this tells you is that actually traversing SQL queries is not easy, right? And that's why I strongly encourage you all to get your accounts going, so you can just write it in and then you get the answer, and then you can check to see which one is the right answer. But other than that, let's look at that. Let's look at what we want returned, right? So what's being returned is R.A, R.B. So the first 2 values are coming from R. Then what we have is S.B. So the second column from S. And then T.B. The second column from T. Okay, so this is what's being returned as part of the relation. Now, what are the conditions? The condition says that you want R.B to be equal to S.A. So second column of R and first column of S, you want that to be the same. And you want S.B, the second column of B, to be different to second column of t. Now let's see how many different ways we can get 0, 1, 1, 0. So we need 0, 1 from R because the first two are coming from R. Then we want that to be the same as the value coming from S. So 1, 1 or 1, 0 could potentially work. And that final value is coming from where S dot B, the second value here, is different to T dot B. So there are two ways that you can get this. You can get it through this combination or this combination. And if you look at that result, 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, you can see it twice. Let's look at this one. 1, 1, 0, 1 does not appear. That's not true because you can take 1, 1 from here and 1, 0 from here and 0, 1 from here, and that will give you 1, 1, 0, 1. And if you look at here again, you get 1, 1, 0, 1. Any questions? Right, so this was a hard question, and statistically, not many people get this right, and this has been the case in the previous offerings as well. Right, so but it's good for you to see how you can check the validity of each of these different multiple choices that you have. Right? You need to try to go through the different tables that you have to see what are the different ways that you can come up and combine these values to get this number. Any question? Mike?
Is there like a formulaic expression, so how many possible solutions appear when you do that? Because I'm just kind of thinking, if you only have one table where there's two options, then you multiply 1 by 2, and if there's S and T have 2, then it'd be 2 squares, something like that?
Right, so here we're doing 1 multiplied by 1 multiplied by 2, which is giving you 2.
Yeah, and then if there were 2 and all 3, it'd be 2 power.
Right, that works. Yes?
I have a question about the SB not equal to TB.
Uh-huh.
When is that ever true?
When is SB not equal to TB? For the ones that are highlighted. The S dot B is 1, the T dot B is 0.
Okay.
Right? No? Maybe? 1 different to 0, so it's... Which part of it is you're not unsure about?
You traverse it like in the same... Okay, I guess...
Well, what you're going to do is, again, think about the cross product first, right? So you're going to take R, you're going to multiply by S, and then you're going to multiply by T. So you're going to get all these different combinations. So that bottom row from S is being combined with all the 4 possibilities from T. And then the ones that S dot B is not equal in TB are the ones that remain, and we get rid of the other. Okay, move on. So approximately, if you have this relational algebra query, you have a bunch of tables and a bunch of predicates and then a projection, that would be similar to this SQL query, right? So projecting, you're selecting A1 to AN, from R1 to Rm, these are the tables you're worried about, and a bunch of conditions that you can also apply inside your selection. The main difference we've seen so far is duplicates. How do we get rid of duplicates in SQL? We use the keyword distinct. So to find the name of actors who've been in at least one movie, which is similar to the one we were doing before, all I need to do is say select distinct names instead of select names. And what this is going to do is, it's going to give me distinct names of people in that relation. Would having a distinct here make a difference? Well, we saw that before, right? Let's try it again. So with distinct, I have 275 rows, and without distinct, I have 316. So here it would make a difference. When would it not make a difference?
In a table where everything's already unique.
In a table where everything is unique, which would mean what?
That everything already has a unique name for the attribute you're trying to select for.
That wouldn't guarantee it, right? Because even if in my table, in my instance, everybody has unique names, that doesn't mean that if I get a different instance for this table, I'm also going to get every name to be unique. But if what I am asking as the attributes to be returned, if that is a primary key or a minimal key for the relation that I'm getting back as my solution, then it wouldn't really matter if I add distinct or not. Right? What I'm getting back is going to be a table. If what I'm asking to see in that table is primary key of that table, or any key, a minimal key, not a super key, as long as it's a minimal key for that, then adding that distinct doesn't really make any differences. But if I was you, and if I was in an exam, and I wasn't really sure whether this is the primary key, would it be giving me distinct values or not, but you know that you want distinct values to be returned, I'll just put it there to be safe. Right? So, if in doubt, and you know that what you want is distinct values, do put that distinct in. Because it's not going to hurt. Even if everything is distinct, nothing's going to change. Any questions? Okay, so the question is, what's the good and the bad about distinction? The problem is, with what we know so far from relational algebra, there was no way to see, for example, how many movies Brad Pitt has played in. Because all you're getting is set. When you say, give me the name of people who have played in a movie, it's going to get rid of the duplicate, so I'll only have Brad Pitt once, and it wouldn't be easy for me to find how many movies he's been in. So the reality is, you can have queries where you would actually want duplicates, and you have queries where you don't want duplicates. And that is why SQL is allowing you to have both worlds. You can have the duplicates as default, but if you really want everything to be distinct, you can add that keyword distinct, and you get distinct values. Right, let's do one more clicker. Sorry, use the other screen. Now let's finish the first round off in 5, 4, 3, 2, and clicks. Right, discuss it with your neighbors.
Just like other side
Can't have
try coffee.
How many
At least for
Alright, let's finish this off in 5, 4,
I mean, you wouldn't want to spread your caramels all over the place.
1. Okay, so select distinct teams. Select distinct, you're keeping team and runs for, and you're looking from score. This is the table that you're going to get back. Now we're just keeping team and runs for. A says 1 appears once. 1 appears twice. And B says 5 appears twice. And let's see, 5 once. The right answer again.
Go down.
Sorry, it's down here. So if you want to fix that, you can, this is on the size of the page, you can change that. You can say sets, page size, 100. And start prepare SQL. Better. Okay, but the question is, we're using distinct, then why are we getting 5 twice? And the answer is that you want the whole item or the whole tuple to be exactly the same if you want distinct to remove it. Right? So in here, I have 2 5s. Here I will have dragons and 5. And the other one is marines and 5. Thank you. I was expecting it to be down there. So because marines and 5 and dragons and 5 are different, then distinct is not going to get rid of one of these. Right? And both will be returned. Question? What if I put distinct in front of runs for? So distinct is going to go through everything inside that tuple. So you can't say, I want this to be distinct on its own. If you want that to be distinct, then you can say, then you can just take out, you can take out the team. If you take out the team and say distinct runs for, then you will only only get 1, 5 because then it's an exact match, and you will only keep one of them. If you put 2 distinct, yes, so you can only have distinct ones. And that would mean that I want the whole tuple to be distinct, not a specific attribute. Yeah?
Okay, so we want to what if we want to show both the team name and the run for? So can we put like select team and then distinct run for? Can we do that?
So what is it you want to show? You want to show the team and
Run for?
so team and run for. So that's what we're showing. But do you want like the sum of the runs or something like that?
Just distinct the run for. Because if we don't put the team there, then it's only the run for is going to be shown.
Well, I guess I think that's the same question as someone else asked, but that doesn't make sense, right? So you're saying I want all the teams, but I want run for to be distinct. So what is it that you would expect to get back? Because for each tuple, you would have either the whole item being there, or you wouldn't have it, right? So if you have team dragons, and it's with 5, and then we have marines, and it's with 5, do you expect to see both of those in what you have in mind?
I think I'm just expecting seeing one team and with the run for 5.
So this would kind of be dragons and marines, and you have 1, 5, and you want both of these to point to the same thing. But that doesn't work out, because for each, you don't have a data structure here to do this, right? You just have items, which are so that means you can either say, I want the whole list to be distinct, or you just can't have anything being distinct. Any questions? A sub B is the right answer. We looked at renaming when we were talking about relational algebra. SQL also allows you to rename attributes. Right? So I currently have role in my stars in, and you can change that to say select title and role as role 1 from this table where that holds. And if you try that, you see the name of that attribute has now been changed to role 1. Why might that be useful? Let's say if you run this as select star, then you're actually going to get so select star why I have 1 star ID here. I should have 2. But generally, and I'll find a good example in a second, is with SQL you can have multiple columns which have the same value, right? This was not the case with relational algebra. Relational algebra said that you can only have 1 column with that name, but SQL doesn't stop you from doing that. That's why it allows you to rename it, so you can call it something else if you have 2 things which have the same name. Yes?
I think the example you just shown has 2 movie ID instead of 2 star ID.
It has 2 movie IDs. I'm sorry, I was looking for star IDs. Right. So you can see that you have 2 movie IDs here, and that's fine. if that's really bothering you, then you can change it and name one of them something else. Now here, what I'm doing is I am finding, let's do that once more. I'm trying to find the title and role. What if I want a movie ID? Should that work? I have two different movie IDs in this table. I have one coming from S and I have one coming from M. So if you run this, you're going to say, SQL is going to get back to you and say that there's ambiguity in that movie ID because I don't know which movie ID you're talking about. And it's actually not clever enough to see that we have this in place. So movie IDs are the same all the time, so it doesn't really matter which one it's going to return. But since there are two different attributes here with movie ID, it's going to say, I don't know what you mean. Specify which one it is you're talking about. Any questions? Okay, so congratulations. You know the very common subset of SQL commands or operators. And there's something we can do with that. Not much. We're going to do a lot more on SQL. But SQL is declarative rather than procedural. And how do we know it's declarative? It's because if it wasn't, then if you wanted to do a join, you had to specifically tell SQL to compute the cross product of these relations, discard resulting tuples if they fill the qualifications, delete attributes that are not in my target list. If I'm using distinct, then go and remove all and eliminate all duplicates. Right? Because this is how you would do if you're writing this in C or Java, right? You have to go through all of these steps and tell the program, first do this, then do this, now get rid of the duplicates. But this is not how we do it in SQL. It's more that you're actually declaring what it is you want, and you don't really care about how it's being delivered to you. For example, let's say you want to find the name of movie stars that play in movie ID 276. Basically, you're just saying that this is what I want. I want the star ID of people that are inside that movie. Now, when the optimizer looks at this query, it says, well, I have two options. I can first look at the join, or I can first look at the selection. I can either first take all the star IDs and all the movies and join those together, and then find the people that are inside this movie. Or I can first find this movie and then only find people that are coming from this movie. So if we run this, all we care about is that Natalie Portman is the only person that's going to be returned. And that's again part of the declarativeness, that we just think about input and what's being outputted, and not about how it's actually being performed. Any questions? Did we move to the next? So I have a new example starting today, so it makes sense to stop here. Any questions about the midterm? Mike?
So it's only up to chapter 4, or?
It's chapter 1, 2, 3, 4, and 19. Any other questions? Yes? Today in your tutorial. Did you get them in the morning? Feedback on? So if you have it in the afternoon, you'll have feedback in the afternoon. Johnny, is that a question? Quiet, please.
Wake up.
The midterm is 65 minutes for the first round and then another 65 minutes for the second round. Question at the back? Quiet, please. Guys?
Format for the midterm?
Do I have a specific format for the midterm? No. I have questions from all of the... pretty similar to the questions that we've been doing in class. So if you feel comfortable doing the examples we've been doing throughout